Okay, we're at the end of our journey. We're going to be presenting our results to the senior leaders and discuss what the action plan should ultimately be. In this last video, what I'd like to do is give you a couple of stories about how to optimally visualize and/or deliver your results. And we're going to discuss two different mindsets, one from the statisticians and the other from the management. I'll then conclude with a couple of mini cases and some ideas on how to best present your results. So, where are we? At the beginning, we had a workshop setting out the objectives. That included also the deliverables themselves. We then looked at all the data, both internally and externally, maybe looked at code that we could use to exploit that data. We cleaned the data and we boiled it down, maybe using some unsupervised machine learning. After understanding our data structure, we then looked into theories or models that could explain the variances in the data that we observe. From there, we used that insight to maybe create some predictive models. Those predictive models largely rely on supervised machine learning. From there, we go into allocation. Okay, I know the way the world works and I can predict the future. What should I do about it? And that's the subject of optimization. After all of that's over, you're then going to have a presentation of your deliverables, of a dashboard, of a graphic, or of some prototype. Question: what are the most important factors to consider when doing those visualizations? I'm going to start our discussion with a couple of good stories. Our first story involves a lecture I attended of Lawrence Klein as a young graduate student. At the beginning of the class, Professor Klein basically told us the following: "You kids are all spoiled. You go to your computers, you type in your numbers, you try to get a high R-squared, you don't like it, you try again, you're not thinking. Back in the good old days, when I invented econometrics, we had to calculate the sum of squared errors by hand. Do you know how long that takes? You have to think first. You people are not thinking. Now, let me tell you, the best method to do analysis is just simply plot the data. So, write a couple of axes and simply put the dots on the board. Put the dots on the board and then you take a bent ruler and you draw a line through the data. That is regression analysis. Any monkey can do it." And then a student in the back of the room would say, "Professor Klein, that was inspiring. But how do you plot the data if there's more than one variable that explains sales?" And then Klein said, "Son, you missed the point completely." And he took his hand and he drew a circle around a dot. And he would say, "Stupid statisticians. Do you know what they call this dot? They call it an outlier. And what do? They ignore it. Stupid statistician. That's not an outlier. That's a case study." And at that point, everyone in the room realized that part of the benefit of doing visualizations is not actually being able to fit the data, but to find data that don't fit the curve, because those data are interesting. What did that person do? They only visited one time and they got a lot of sales. Who is that person? What did they do? I want to know about that data. And Lawrence Klein, for the rest of the course, taught more about variance decomposition of errors than actually how to fit a curve, because fitting a curve is actually kind of trivial. So I learned a few lessons that day. The first is, I'm a monkey. The second is, it's relatively easy to fit a curve to a bunch of data. But more importantly, maybe the money is how one interprets the data. And in particular, we want to know what the model doesn't explain. A small little trick is, if you ever show a scatter diagram, put the name of the person or the name of the market or the country, name the dots, put the words on the graph itself. Then maybe give those dots a name that everyone can refer to, like the Sally method. Something Sally did is very different than others. In addition, you may want to add to the graph kind of what the dots above and below a line mean. For example, people who spend so much time or fixed cost on a client and yield very high sales, well, let's call those high yielders. The ones below a line, the ones that don't produce as much sales for the same amount of investments, let's call those low yielders. So when you present any graphic, always overlay words so that people can interpret what the graph means, and do not delete any outliers. Show them and have an explanation for them. My next story involves Spyros Makridakis, basically the person who invented the field of forecasting. Spyros has published a number of articles on methodologies to forecast data, and he created the M competition, where he sends out hundreds of time series datasets to different researchers and asks them to compete. Who can come up with the best forecasting model? The most downloaded paper recently in the field of artificial intelligence is his 2018 paper, Statistical and Machine Learning Forecasting Methods, Concerns and Ways Forward. I strongly recommend that anyone in this field read that paper. It basically does a competition between old school methodologies, or what people used to call statistical methods, and modern machine learning methodologies. Basically, in the old days, we had different ways of extrapolating data over time to come up with forecasts. Recently, those old methods have been improved upon by automating the process of selecting the optimal time series forecasting model. Great. In the modern methods, we have neural networks, deep learning, an alphabet soup of different methodologies that we can apply. What Spiros has done with his co-authors in that paper is simply compared which methods perform better. And it turns out the old school wins. In that paper is a killer visualization, one that is very appropriate for leadership. Let's assume that you're in the business of forecasting, and the more accurate your forecast, the more likely you can earn money. So, what do you need to do? On the horizontal dimension, list all of the methodologies that you've actually applied. Then, on the vertical axis, put the label of the objective. Now, in this case, high profitability is low on that vertical axis. High risk is at the high level of that vertical axis. In this case, we see that the best methodologies, i.e. the ones that yield highest profits, actually are the older statistical methods. The more risky methodologies are the machine learning methods. This is a wonderful way to present alternative methodologies on the same dataset. And you should use multiple methodologies because results are often method specific. Over the years, I've come to realize that in the area of visualization, there are really two different worlds out there. There's the world of the statisticians and the data scientists and the machine learning people, and then there's the world of strategic leaders. In the world of the statisticians, they'll often show visualizations that are method driven. For example, they'll show scary spider diagrams, dendrograms, maybe some clusters or elbow plots or perceptual maps. Those are all unsupervised machine learning graphics. Or, in the world of supervised machine learning, they might actually show a QQ plot. These are all very, very useful curves, no doubt about it. But when they're presented to the leadership, often there's a disconnection between what those graphs tell you and what leaders actually want to see. Leaders, on the other hand, they're using things like line charts, bar charts, pie charts, and if they're very clever, pie charts on top of bar charts that actually form little lines. How do we bridge these two different mindsets into a single graphic? I'd like to share with you a couple of mini cases on this very subject. In our first case, let's consider a simple problem. I want to know how many distributors to have in a geographic location. We might apply cluster analysis to help us determine this. On the far left side, you'll see a graphic. Each blue dot represents a concentration of customers. In that graphic, I have to decide how many distributors I want to have and where should they be geographically located. Right now you'll see a star in the middle of that graph. Question, is 1 the right number of distributors? Or perhaps there are clusters of customers, and in each cluster I could have one distributor. Well, typical statisticians will use something called an elbow plot. If there's only one cluster, we'll notice that there's high inertia. There's a lot of distances that have to be traveled by the various customers to get to that distributor. If I have two clusters, you'll notice that the elbow plot has a lower value. In other words, 2 clusters actually has lower inertia. That's a good thing. Eventually, with 3 clusters, it's even better. 4, even better. So typically, a statistician will look at an elbow plot and they'll say, well, look at the elbow, and that tells you that there might be about 3, perhaps 4 different locations where distributors should be located. And you'll end up showing a graphic like the one on the right. That one shows us 4 different locations represented by 4 different colors, and we'll have 4 distributors. Question, is this the right answer? This graphic to managers actually is completely irrelevant because managers want to know what is the number that maximizes profit, not the number that actually is at the elbow of an elbow plot. Okay, so what is the appropriate visual? As you recall from step 5, determining the optimal number of something is a control or allocation problem. In this case, let's apply response analysis and see what we get. For this discussion, let's assume a distributor is a salesperson, and we're simply trying to understand where those salespeople, where those distributors should be located, and which customers should be assigned to each salesperson. Let's assume we already have 10 distributors, and the organization they work for has about $22 million in sales per year. In response analysis, we'll then ask a few additional questions. For example, what if we never would have had those distributors? What would have been the sales of that team? Well, with no distributors, we might only get $1 million in sales because we have some accounts receivables. That's called brand equity. Now let's ask, if we had 15 more distributors, how much more sales might we have? Let's say that would be about $26 million. That's called headroom. And then finally, what if we had as many salespeople as we ever could hope for? An infinite number. Let's call that the ceiling. Let's say that's about $52 million. From this, you're going to be able to plot a response curve. Now, we're located right about here with 10 people. Question. Should we have more or should we have less salespeople or distributors? Well, that depends. It depends on the cost of a salesperson or a distributor. Let's assume they're $300,000 per year to hire. Secondly, it depends on the profit margins from sales. We have to cover the cost of goods sold and the salespeople. What managers need to know is what's called the contribution curve. It's a plot between the levels of distributors and the actual profitability of the organization, knowing that those profits already cover the salaries of the sales force. That leads to a contribution curve. Where's that contribution curve maximized? At about 20 salespeople. In other words, given the profit margins of this business and given the cost per distributor, we should not have 10 distributors. We should actually have about 20. We should increase. But if you go beyond 20, what happens is there's simply no more market to be had. They do not cover their cost. Therefore, contribution goes down. During step 3 of our 5-stage process, you would learn that this is called the law of diminishing returns from the field of economics. This contribution curve is the holy grail curve to the CFO. They don't want to hire too many people, but they don't want to hire too few people either. Therefore, we know that on the elbow plot, we need to have about 20 clusters, 20 locations. And then we get finally cluster analysis to help us determine where they should be located and which customers they should be assigned to. With those 20 people assigned to different customers, we'll notice that our actual profitability, our shareholder value increases from $6.9 million to $7.3 million. That's a 6% increase. To get that increase, we need to have a sales target of about $29.7 million. Those are the numbers that leaders need to hear. Now, that process might have taken us only about a month of analysis to complete. That might cost about $20,000. $20,000 to return $6.9 to $7.3 million. That is a crazy return on investment. This is why data analytics is so powerful. Another thing you'll learn from this exercise is the words that managers use may not be the same words used by analysts. Managers use words like brand equity. A statistician might use the word bias. Managers use the word plan. Statisticians might use the word anchor. A manager might say headroom, but a statistician might say the delta. A manager might say ceiling. A statistician says asymptote. A manager will say response curve. A statistician will say sigmoid. A manager will say contribution curve, and a statistician will say gradient. Bridging the linguistic divide is a bit of a challenge, but fundamentally, we could not have gotten here had we not used a number of cool machine learning tools. For example, we need to estimate the level of sales at the different levels of distribution or sales force numbers. That's a supervised machine learning tool. We need to extrapolate where the customers are geographically. We might use Kriging. To do response analysis, we'll use the Delphi procedure, but to determine which customers are assigned to which salesperson or distributor, we'll end up using cluster analysis. Of course, we'll compare many different methods to get to this final conclusion. And there you have it. Analysts, statisticians, people in the field of machine learning need to speak like leaders, but they have to have rigorous models to support their findings. In our second mini case, Imagine the scenario where you would like to give a micro loan to a farmer in rural Africa. They have no credit score, but you would like to know their credit worthiness. Is it possible we could ask them a few questions and come up with a credit score? In order to do credit scoring, banks traditionally use a number of questions, many questions, before they give you a house loan or a car loan. Well, if we did an audit of all the different questions that are asked by banks, you'll find hundreds and hundreds of questions. Many of these questions are correlated, so we might use a form of factor analysis to boil these questions down to only a few. In fact, we might use something called hierarchical factor analysis and a few fancy techniques to boil it all down. This will then lead us to just a few questions we can use to predict someone's creditworthiness. And we might come up with a model, perhaps a logistic curve. Will the person pay the loan back or not pay the loan back? And once we determine those variables that are highly predictive of creditworthiness, we'll conclude that maybe we want to have just a few questions. But how many questions? If we ask too many questions, people won't finish the questionnaire. If we ask too few questions, we may miss valuable information that could indicate someone's creditworthiness. So, we're going to look at an ROC curve. Basically, on the horizontal axis, you'll notice something false positive rate. Basically, we don't want to give a loan to somebody who's not going to pay us back, but we also do not want to not give a loan to someone who could pay us back. So we want a very low false positive rate. What we really want is a true positive rate that's very high. We want to not lend to people who will not pay us back, and will want to lend to people who will pay us back. The blue line is the perfect curve. Everyone will get a loan who should get a loan, and people who should not get a loan are never given a loan. In essence, if you have a 45-degree angle line, you're really not doing much with your methodology. You want to maximize the area under the curve, the AUC. Based on the AUC of this analysis, it looks like anywhere from 5 to maybe at most 15 questions is more than enough information to give someone a credit score. Question, is that the right answer? Well, maybe not. Statistically, it looks pretty good, but we're not here to answer a statistical question. We're here to maximize shareholder value. Or maybe not. The reason I've said maybe not is because many organizations, when they do micro-lending, actually want to have social impact, not just financial impact. They want to increase financial inclusion. The example on the previous page was about asking questions via a mobile phone network to the world's poorest people in rural Africa. Now, this doesn't mean that they can lend at a loss, but it does mean that they might want to consider lending to as many people as they can without losing any money. Maybe they just want to break even. That distinction is extremely important. Let's look at, for example, the contribution curve for questions. On the horizontal axis, we have number of questions, and on the vertical axis, we have contribution to shareholders, or profits. Let's say our analysis concludes that we need to ask 10 questions. Asking more than that, and less people will actually fill out the questionnaire and they won't borrow any money. So 10 looks pretty optimal. Now let's consider another supervised machine learning model. Another constraint, if you will. On the horizontal axis, we have number of questions. On the vertical axis, we have the number of loans. Now, we might think it's a linear line, but empirically, we may discover that it's not linear. In fact, you ask even one question, and people will simply not fill out the questionnaire. You will never have the opportunity to lend to these people. Why? Maybe because there's low literacy rates. Maybe because the questionnaire is not translated into local dialects. Maybe because, well, people just don't trust questions on a mobile phone. So, we need to think about something more than just the optimal number of questions to ask. We need to think about the marginal cost for each loan, the cost of marketing to encourage people to answer the questionnaires, the cost of non-payment, and many other factors that possibly can affect profitability. In fact, if you use the 5-step strategic planning process, at step 2, you would have done an audit of methodologies where people do micro-lending using different types of data inputs, not necessarily questionnaires. Here's a list of a few of them that one would research if one is going to consider credit scoring methodologies. And at the end of the day, you might discover curve B, whereby you simply ask no questions, but rather rely on data related to the mobile phone traffic of that individual. This may serve better an organization that's trying to increase social impact or financial inclusion. If this sounds familiar, it is. It goes back to the methodology of Spyros Makridakis, where you use multiple methodologies to come up with the optimal answer. The bottom line is, people from the field of machine learning will be talking a lot about their data to actually create new and interesting models. They'll talk about a training set of data, and a validation set, and maybe a testing set where they can see if their model is performing well. Then they'll put it into the field with a pilot test perhaps, and call that a vetting set of data, just as a sanity check. They will have a number of very cool graphics that describe the performance of their various models. On the other hand, managers have their own metrics. My recommendation, before you start a project, is sit down and brainstorm over those management metrics first. Understand that whatever the models are, they are going to have to map into profitability, social impact, or some other objective set by the management team. From there, the machine learning metrics will still be used, but they exist to derive a final representation that's useful to managers. Okay. There you go. We're at the end of the journey. What did you learn in this video? A few things. First, you want to explore outliers. Don't throw them away. Second, use a lot of different methods. They're very quick to do, so why not use them? Next, plot your findings against managerial metrics like sales or profits. Always research existing applications that might be out there, and never forget to create rough drafts of your visuals before starting the project. Okay, that's about it. Enjoy the rest of your learning journey. Bye-bye.